Hello, this is Denton Yoder, instructor for BSE 2304, the Biological Systems Engineering CAD class. We have in the past already made surface models a couple different ways. We made a surface using contour data. We also included block data that were spot elevations. We fixed spot elevations. We also imported points, survey points, and made a surface from a group of points. But today I want to talk a little bit more about what is this surface thing, why are we doing it, a few of those questions. Okay, to start off with, what I'm going to do is talk about why you need a surface. What a surface is going to be is a math grid for us. I'm going to type in point, put a point on the screen, hit enter, put another point, enter, another point, enter, another point. I'm simulating surveying a football field. All I need are the four corners for the computer to make triangles for a field. Two triangles should cover every square inch of a football field. The triangles represent lines of interpolation between the points so that the elevation from the first point to the second point is known, and the elevation change to the next point, forming a flat surface or triangle. This field is covered by two triangles. A line of interpolation is going up through the middle. If we think of it as a sheet of paper, I could raise opposite corners and keep a pencil across the middle, and the two triangles would be dipped in the middle, where a football field would be more flat. Any kind of a flat or constant surface can really be modeled with a very minimum number of triangles. Now, I'm going to change this. Let's erase these and these. Erase these. Okay, if I wanted a crown in the middle of the field so that the water drained away from the center of the field, I would have to put a higher elevation in the middle. By doing that, now I'm introducing more triangles. So by adding those 2 points, I've doubled the number of triangles, and now I'll have a slope away from the center towards the outside ends. Well, what if you wanted a cross-field slope up or down? Well, same thing. You could add a couple points. Let's say point here, 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 here. Lines, triangle on the left, triangle on the right, triangle on the bottom. Okay. So now I could have both a slope, have a high spot in the center, sloping down to the sides and down towards the ends. I could do it with just 9 points. Okay. That is a basic example. Now, what if I had a rock? I'm going to draw a circle here and say that's a rock. Now, if that rock was in the middle of my field and I wanted to see this, I could have a point at the corners of my field and a point right on top of the rock. If I did that, the triangles would actually peak on the rock. And what this would look like to the computer is a cone or a pyramid where you have a higher elevation in the middle and it's slowly sloping out to the other sides. So this is bogus. I need to erase that. What we would need, in addition to a point on the top of the rock, is we would need a point outside of the rock. Well, let's have it. I think I'm getting a center snap on. Need to turn snaps off. I would need points around the rock and if you want to know that it's a rock and not a pyramid, you'd want more points on the edge of the rock. And then when we triangle this together, turn my snaps back on. Actually line. Get something pretty interesting looking really quick. Okay, I think that actually is how the surface model would look, where it's making a bunch of triangles from the corners into the elevations that are on the bottom of the rock on the outside, and then it would slope up to the rock. Up, I'm missing one right here. Two, actually. Okay, so it would be sloping up to the second level and then sloping up to the third level. So you'd actually get a 3D shape. Well, what I'm trying to show here is that with 2, 4, 6, 8, 10, 12, 14, 16 points, I made a nasty looking rock. So I could do an entire football field with 4 points, but I could have an inaccurate version of a rock with 16. Big major difference here. I want you to understand that. Now, if we were to look at a channel, okay, I'm going to just erase all that. I'm going to use a command. I don't know if you've seen this one. Sketch. What it'll let me do is draw a channel for a creek. So I've got the center line of the creek, and, well, let me do the point command. I'm going to turn my snaps off so I can just eyeball, but I'm going to do a point here at the center of the creek. The bottom of the creek, I'm going to declare as this, and there's a bank that has a different slope at different regions. I think I might need to drop down here. I may be able to go all the way to the end. The other side, I need to Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I used 22 points to model this stream channel. So, if I were making a surface and I was surveying a creek, I would be doing these 22 shots, then walk down the creek some amount, and I have to decide how far that is, and do it again, and then walk down the creek and do it again. And we would call this a sequential series of cross-sections. And what I'm looking for are grade breaks. Where does the grade change from being flat to going uphill? Where does the grade change here from going uphill to being diagonal? You know, here's a steeper, less steep, more steep, less steep, more steep, flat. Those are grade breaks. Now, I'm going to erase that and answer my phone. Okay, back to work. We just did a cross section. Now, I'm going to do another sketch command, and I'm going to draw what the sketch command. I'm going to draw what the creek looks like. So what we were doing was making a cross section on this creek perpendicular to the creek. Now, we have data here and we have data here. It's going to be really accurate on the inside of this curve, but it's going to be really inaccurate on the outside of the curve. So we really should have more data to interpret a cross-section between when there's a sharp area. When it's very straight, what the computer's going to let it do is take the shape of our one cross-section and the shape of our other cross-section and connect the dot with those 22 points to make triangles over that space. And we have to determine whether that spacing is accurate enough for us. And we typically turn the cross-section to be perpendicular to the stream section as we go. If there's a turn, we have to judge how sharp to calculate it, and if we go too far, we better go back and pick one up in the middle. If the channel shape is different from one cross-section to another, you may need an extra section. When there's a bridge, we typically would put a section 1 foot in front of the bridge, do both edges of the bridge, and then do a section 1 foot off the bridge again. That gave us a 1 foot horizontal distance to change what we do over the bridge. Well, hopefully you get the idea of what that survey is going to look like. Okay. Another topic to talk about is point groups. Actually, let me just talk about it first and then I'll demonstrate it. And